Hi everyone, welcome to Vedantu NEET English. I'm Diksha Kaushal, your chemistry master teacher, and so sorry about the delay of the class. Actually, the studio was not working fine, and I didn't want you to take any risk. So I thought firstly let us correct the studio. So after that only, because the class is going to be long, right? So I don't want any interruption in between the class. So that's why I delayed the class for 1 hour, and here I am with you. Right, today we are going to do day 2 of most important concepts of chemistry for NEET 2025. Yesterday we did some concepts, right? Today we are going to do physical chemistry concept firstly. After that we'll jump to organic chemistry. Okay, so everybody, if I'm clearly visible and audible to you, then let me know in the comment section so that we can start with the day 2 of chemistry. Okay, so yesterday I saw so many comments, right? Such beautiful, amazing comments I saw yesterday, right? Let's see who all commented yesterday. Let us see yesterday's lecture. Okay, so I can see uh, uh, Anant, Harish, Sindhu, Roshni, Mardei, Priyanka, thank you, beta, Angel, Hyper, Krishna, Raj, Meghna, Shri, Mohan, Aditi, Athik, Sahil, Nitin, Sukhmeet. Thank you so much, all of you. Thank you so much for all the appreciation words. So today we will be doing this thing, that is concept number 2, right? Okay, sorry, day number 2. Let us start that without wasting any time. Okay, let us start that without wasting any time. So are you all ready? If you're ready, then green hearts, fill the start with green hearts in the comment section, and let us start with our journey. Yesterday, crush shots gone viral. Yeah, the team is there for, picking up the shots from the lecture. So the team is working really, really good on that, right? We to just speak everything that is in our heart. We never know that is going to get into converted into shots. Okay, chalo. Okay. So firstly, beta, I'm going to start the lecture with this we have done, this we have done, this we have done. So firstly, I'm going to start with thermodynamics. Okay. So from thermodynamics, if you see this, from thermodynamics, directly formula-based questions they will ask you, right? Some important concepts are, first is heat capacity. It's a very, very important concept, heat capacity. Then let's talk about heat capacity and work formulas. And work formulas of all the processes, right? These two. And the last one is Gibbs-Helmholtz equation. Gibbs-Helmholtz, the spelling may be wrong, right? So Gibbs-Helmholtz equation. And the last one is relation between delta U and delta H. So from these four concepts, or I would say first two are concepts, last two are not even concepts. These are just equations from where the questions are asked frequently. Okay. So firstly, we are going to talk about work here. For work, what you should know, that what is the first law of thermodynamics in chemistry. Okay, so first law of thermodynamics is delta U, that is the internal energy is equals to Q plus W. This is heat and this is work done. So internal energy is the sum of heat plus work done, that we know. But if you have learned this formula, you should also know the sign conventions here. So how do you know the sign conventions? Always remember, if I say that you have to give money to someone, you have to release money, then you will be feeling very negative. If I say someone is giving you money, that means someone is giving you the money, that means you are absorbing the money. That means you will feel very positive. So these are the sign conventions. Next is about the work done. So if you talk about the work done here, tell me, if I say that work is, here I'll just write it, this is released, heat energy is released, this is absorbed, this is absorbed. Now, talking about the sign conventions of this work done, if work is done on the system, work is done by the system. So students, if work is done on the system, someone is doing work on you, okay, then you will feel happy. Someone is doing work for you, you are feeling very happy, so that means it is positive. If work is done by the system, if you have to do the work, then you will feel very negative. I have to do the work, right? So you will feel very negative. So overall, the sign conventions are heat energies. If someone is giving you the money, you are feeling very positive, you are absorbing the money. If someone is taking out money from you, you have to release the money, you will feel negative. If someone is doing work for you, work on you, then you will feel positive. Yes, I am free, I don't have to do anything. But if ma'am says that, okay, beta, you have to do these questions by yourself, you are like, oh, I have to do these questions by myself, then you feel very negative about it. Okay, so these are related to your real life only. By this, you can remember the sign conventions of the first law of thermodynamics. Okay, you don't need to cram anything, just remember this with the help of your daily life, what happens in your daily life. Okay, right. Now, next is graphical representations. So, beta, here you just remember that in isobaric, pressure is constant. Isothermal, temperature is constant. When temperature is constant, internal energy is also zero, right? Adiabatic process, Q is constant, here T is constant, and here delta P is constant. Isochoric, here delta U, not delta U, here delta V is constant. When temperature is constant, then delta U will also be equals to 0. So this was the overall processes. Now let us go into the important part. This we have already done. Isothermal, delta T is constant, that means delta U is constant. If delta U we are saying is constant, it is not changing. In that case, if you put this in this equation, then Q will be equals to minus W, right? Here delta H will also be constant. For isobaric, delta P, for isochoric, delta V is constant, that is why work is constant, that is why putting this in the first law of thermodynamics, that is delta U is equals to Q plus W. If this is 0, then delta U will be equals to Q. Adiabatic, Q is 0, that is why if you put Q is equals to 0 here, then delta U is equals to work done. Okay, so you just need to know the definitions and then put it into the first law of thermodynamics. You will yourself get these kind of equations from there, right? What you need to know, just know that what is the definition, what is the meaning of these processes, and for that put that same equation in the first law of thermodynamics, then you will get these kind of relations. Now next is the work done. Ma'am, do I need to learn the derivations of work done? No. Okay, before work done, now you need to know one thing here, that is what is the difference between reversible and irreversible process. If you know the difference between reversible and irreversible process, things will be very simple for you. Okay, so how they will ask you the numericals, reversible and this is irreversible. This is irreversible. So just understand one thing. For example, you have a beaker, right? And this is the piston, right? Similarly, here you have a beaker, right? And here this is a piston. Okay. Now you are decreasing, or you can say you are increasing the pressure. You are changing the pressure by adding some sand here, right? Small amount of sand or soil or any particles, small particles, right? In this, you are increasing the pressure by adding some big block, okay? By adding some big block. So now what you will see here, that whenever you are adding small sand particles and when you are adding big mass, big block here, so what will happen here? Here the pressure will increase in slow steps. That means this will be a multi-step thing. Multi-step. Okay. Here the pressure by the piston will applied in multi-steps. And here the pressure will be applied in just one step. Okay. Just one step. Here you can say, because multi-step, it is a very slow process. Right? It is just one step, that is why it is a fast process. Right? Now I am writing some very important line here. Whenever they have not mentioned whether this is a reversible process or irreversible process, they will mention one thing here, that is at variable external pressure. Variable external pressure. So the pressure that you are applying here is variable, it is changing. Sometimes this pressure, sometimes this, sometimes this, sometimes this, sometimes 3-4 dots, 3-4 particles, they will apply pressure. Sometimes 2 particles will apply the pressure. So according to that, it will change. Here you have at constant external pressure. Okay, this will be at constant external pressure. Because of that, here what you will use, especially in case of isothermal, this question is asked. So here, because of the variable external pressure, you will use integration formula. Here you will use integration formula. Okay, but here you will not use integration formula. Here you will use direct work formula. Direct work formula, no integration is needed. That means delta formula you will use. Because integration, that means if you have integration and differentiation, this is for small step. This delta is for large step. So that is why here you will use integration formula, here you will use simple formula. And this thing is there only in case of isothermal. You will see this only in case of isothermal. Firstly, tell me if this thing is clear to you or not. Is this thing clear to everybody or not? If this is clear to you, then I shall start with the formulas of the work. Yes, very good. Then I should start with a very good constant external pressure. Very good. Now, if you see this here, these are the processes, and these are the expressions for the work, right? So what we are going to do here, this is work is equals to minus nRT ln of V2 by V1. I think you are able to see this, है ना? So this is basically the work done formula in case of reversible. In reversible, we use the formula which has integration involved here. So that is why this formula we are using here, which is the result of the integration. So here what we have, natural log of V2 by V1. But if we have, for example, we are talking about pressure. They have not given you the change in the volume. They have given you the change in the pressure. Then the answer will be P1 by P2. Okay. So then if you talk about internal energy in case of isothermal, that is 0. Delta H is also equals to 0 in case of isothermal. That is the reason putting this in first law of thermodynamics, delta U will be equals to Q. Right. So that is the reason here Q will be equals to the same thing that we have done for work. The formula of work done and internal energy is going to be same, right? Sorry, the work done and the heat is going to be the same. Next is, if you have irreversible process, as I told you, for work done, the formula is minus P delta V. So you will use the direct formula minus P external delta V, right? So here minus P external will stay as it is. We know that PV is equals to nRT. From that, V is equals to nRT by P. You just put the value here. This is nRT by P2. This is nRT by P1, right? And the formula you can easily answer. Okay, you can easily say this here, minus nRT P external. This is 1 by P2 minus 1 by P1. That will come out to be the answer, right? Okay. Next is, next is, if you talk about the Q, expression of Q, we know that that will be equals to, Q is equals to W only. So answer will be same here. Delta U, delta H are 0. These are the formula of work done of isothermal process. For isobaric, it's very simple because the pressure is constant. So directly you can apply the formula minus P delta V, or you can also convert it into minus NR delta T. Right? Reason is because pressure here is constant. So gaseous moles are not changing, but temperature is changing here. Right? So you can also apply this formula. Isobaric, very rarely they will ask you. Mostly they will ask you irreversible or reversible. These are the two most important formulas for your thermodynamics, right? Very, very important. Now, if you talk about at constant pressure, we know that at constant pressure, what will happen? QP will be equals to, this Q will be equals to delta H, that is nothing but NCP delta T. This formula we have taken from heat capacity that I'll teach you. Okay, so Q will be equals to delta H and U will be equals to NCV delta T. Okay, understood? Got it? Chal. Next is, if you talk about isochoric process, work done is 0 because delta V is also equals to 0. That is why work done is 0. Here Q is equals to, so basically let me tell you one thing, why we have written Q is equals to delta H. When we will study this thing, that Q here is nothing but QP. Okay, Q here is nothing but it is QP. And QP is always equals to delta H. This is a very important formula, right? And the formula of delta H is NCP delta T. Formula of delta U is NCV delta T. Okay? Here, when you have Q at constant volume, that is equals to delta U. Very, very important formula. That is why it is NCV delta T. Okay, these two are very important formula, this one and this one and this one. Okay, these are very, very important, that at constant volume, heat is equals to delta U, at constant pressure, heat is equals to delta H. Right. Now, these questions, these two formulas, reversible and irreversible adiabatic process. If you see this here, the formula is NCV. So we know that here Q is equals to 0. So what you will have, W is equals to delta U. Right. So delta U, we know that delta U is equals to NCV delta T. So that is why we have put this formula here. Right. Now, this can also be regarded as P2 V2 minus P1 V1 gamma minus 1. Okay, so this is the formula of work done, right? This is the same formula of work done for irreversible process, right? But here you will try to find the value of, if you want to find the value of T2, you will find the value of T2 either by this equation or by this equation or by this equation. Okay, keeping it T1, T2, you will find the value of final temperature by this equation. But if you want to find the final temperature of irreversible process, then you will find it by this particular equation. Okay, you will equate this equation with this equation, then you will get to know the value of T2. Okay, understood? Majorly, the questions that they will ask you is from this one, right? Isothermal, reversible, irreversible, or QP and QV. These are the most important questions. Okay, most important questions. Now, next is heat capacity. If you talk about the heat capacity, here heat capacity is the change of heat when you increase the temperature by 1 degree Celsius. The main important part here is the total heat capacity is called as delta Q by delta T, right? And molar heat capacity, that we will represent by Cm, or you can also represent this by Cs, that will be molar heat capacity. You will divide this by number of moles. Okay, so that will be your molar heat capacity. If we are talking about, let's say this is C is equals to Q by delta T. I am talking about heat capacity at constant pressure. This will be QP by delta T. What is QP? Anybody in the comment section? What is QP? Anybody in the comment section? I have just told you what is QP, right? So as I told you, simple, it is going to be Q by delta T. At constant pressure, it will be QP by delta T. At constant volume, it will be QV by delta T. What is QP and QV? What is QP and QV, beta? What is QP and QV? What is QP and QV? QP is nothing but it is delta H by delta T. QV is nothing, it is delta U by delta T. If you divide it, if you want to calculate the molar heat capacity at constant pressure, this will be CPM. a molar heat capacity at constant volume, that will be CVM. Then you have to divide it by N. That is how you got this particular formula. That is delta H equals to NCPM delta T. Okay, the first formula, very, very important. Here you will get delta U is equals to NCVM delta T. Very, very, very important formulas. Okay, understood what we are doing here? This is CPM, CVM. Okay, at pressure it is QP, at volume it is QV. That is equals to delta H, delta U, right? For molar heat capacity divided by number of moles, right? That is why I would like to correct this here, right? Because the representations are very important for you, right? Okay. So if you're talking about molar heat capacity, next is going to be this. You can say CVM, this is CPM. This is the formula that I was telling you. Okay. Is that clear? These two formulas directly they are asked. Very, very important. Directly these two formulas are asked. Okay, beta, I am only picking up the most important formulas from thermodynamics. Okay. Now, if you talk about relationship between CP and CV. So, relationship, how do you remember that? See, don't go through NCRT after this, because in NCRT, in the bracket, they have mentioned 1 mole or something. That is why I have changed the denotions only. Right? So, here it is CPM minus CVM is equals to R. If you talk about CP minus CV, that will be equals to NR. Right? That means CP divided by N, that is nothing but CPM. CV divided by N, that is nothing but CVM. That is equals to R, that we have mentioned here. Right? These are the relations. Now here if you talk about CVM, this is also PM, this is CPM. See, in the exam, maybe they will, instead of mentioning CPM, CVM, they will only say CP and CV in the exam. Right? Okay. If they are talking about 1 mole, that means they are talking about this thing only. Right? Now here, remember one thing, that when you talk about CV, that is degree of freedom multiplied by R by 2. CP is equals to R plus CV. Right? And gamma, that is the Poisson's ratio, that is equals to CP by CV. From there, we can say that this is the table that we were waiting for. Monatomic gases always have degree of freedom 3. Diatomic or linear triatomic. See, monatomic gases like helium, neon, right? These are monatomic gases. Diatomic gases like H2, N2, O2, these are diatomic gases. H2, N2, O2. Linear polyatomic, any idea about any linear polyatomic molecule, guys? Any linear polyatomic molecule? And what are the degree of freedom? Degree of freedom are 5 here. Okay? For non-linear polyatomic, degree of freedom are 6. Now give me the example of linear polyatomic and non-linear polyatomic. Linear polyatomic, like more than 2 atoms which has like carbon dioxide. So example is CO2, right? Here the example is SO2, which is having a structure something like this that we did in yesterday's class itself. So it is non-linear polyatomic gas. Okay, understood, clear. So according to that, if you put the value, we know that CV is equals to FR by 2. This is, that is why 3R by 2, this is 5R by 2, this is 6R by 2, that is 3R. Okay, we know that CP is equals to CV plus R. So this will be 5R by 2, 7R by 2, this is 4R. Right? After that, just calculate the ratio here. This will be 1.6, 1.4 and 1.33. Very, 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 very important. Either they can directly ask you the value of gamma for some gas out there. They will not give you whether it's monatomic, diatomic. You have to know the structure by yourself, and then you will get to know what is the value of gamma here. Right? Gamma questions, beta, very, very important. Simple question it is regarding what is the value of gamma or what is the Poisson's ratio, or they can ask you what is the value of CP by CV. Is that clear to everybody? Is that clear to everybody or not? Yes? Okay. Chalo. Now, let us talk about 2 major formulas of thermodynamics. First is enthalpy. For enthalpy, always remember what you have to do here. For enthalpy, delta H is equals to delta U plus delta PV. Now here I am taking that either pressure can be constant or volume can be constant. I have no idea about it, right? If pressure is constant, then this will change to P delta V, right? If volume is constant, that means this will change to delta H is equals to delta U plus V delta P if volume is constant. According to that, your formula will change here. Now there is one more formula, that is delta H is equals to delta U plus, here it will be delta NGRT. Okay. So basically this delta NGRT is nothing but number of gaseous product minus number of gaseous reactant. Here we are talking about the gaseous products and gaseous reactants. Acha. Can we also write it in the form of QP and QV? Anybody? Can we also write, because this question has been asked. Okay. So this can also, we know that what is the value of delta H? Anybody in the comment section? What is the value of delta H? Is it QP or is it QV? Third time in today's class I am asking you this. Now I want the answer in the comment section. Is it QP or is it QV? Yes. Yes, most important class for a reason. Yes, you are right. Absolutely, Sukhmeet. This is the most important class for some reason that I am writing here. Right? Okay. So this delta H is nothing but it is Q. What is P or U? Very good. It is very good, Karti. It is QP. Right? And what is delta U? That is QV. Very good, Karti. Sukhmeet, Meghna, Malesh. Very good, very good. Okay. So this is also the form. You know, sometimes they confuse you like this. Some important things. Sometimes they will not say enthalpy of the reaction is this internal energy. No. They will instead say heat energy at constant pressure is this. Calculate the heat energy at constant volume. You will get stuck, ma'am. What is this formula? What we have to apply? This formula. Now, ma'am, when we have to apply this formula, you tell us, ma'am. Okay, this can be QP is equals to QV plus delta P. Now the question is, should I apply the formula of pressure and volume or should I apply the formula of delta Ng? So remember, if you are given with some chemical reaction, you will use this formula. If they have given you pressure change and volume change, right, fixed constant external pressure or volume, then you will use this formula. Mostly they will ask you this formula. According to my experience, they will ask you this formula. Reason being, because high chances are they will ask you question where they will ask you at constant pressure, this is the change. What is the change of heat at constant volume? This is the reaction, that's it. Now you will see, ma'am, nothing is given in the question, because in the question R, so you should already know. Temperature will be given to you in the question. Delta Ng, you can answer that according to the reaction, right? And that's how you will use this formula, right? Okay, yes. Now, next is regarding entropy. Before entropy, I would like to tell you this particular formula that is more important, right? Entropy formula, it's not like they very frequently ask you, but I have written it here so that the students who just want to do this much for thermodynamics, you were like, ma'am, I just want to do this much for thermodynamics, then remember this one more formula. That is my advice to you, right? If you want to skip this, you can, but that would be a risk. Okay, this formula so you can't skip, right? If you're skipping this, then you are stupid, right? Okay, let me be very clear to you, because this formula is for sure they will ask you this formula in the exam, right? 100% they will ask you this formula. It is the most repeated question. Let's talk about NEET or you talk about JEE. Repeatedly they are asking you, because the agency that is conducting is same, that is NTA, right? So we have to go through everything here. In attempt 1 of JEE, they have asked this question in all the shifts. That means in NEET also They are asking this from previous so many years. That means the trend is still the same, right? So here, what exactly? This is called Gibbs-Helmholtz equation. That is delta G is equals to delta H minus T delta S, where they can ask you what are the conditions where delta G is negative, that the process can be spontaneous, right? What are the conditions where delta G will be positive? Let me tell you one of the conditions here. So if you say that delta H is positive and delta S is also positive, then T delta S should be greater than delta H for the spontaneous reaction, so that this overall delta G can be negative, right? If I say this is negative, this overall, this will become positive, then delta H should be greater than T delta S for our reaction to be spontaneous, for this overall equation to be negative, delta G to be negative. If I want to see at which condition in all the cases you will have, just give me a second. Okay. If I ask you at which condition delta G is going to be negative always. So if you have this negative and this positive, right? Then in all the conditions, delta G is going to be spontaneous, isn't it? Isn't it? If this is negative, this is positive, then this overall will always be negative. That means this overall situation will always be spontaneous, isn't it? Now, tell me that particular condition. Wait a minute. Okay. Now, tell me that particular condition where this overall will be always spontaneous. Where this overall will always be spontaneous. Anyone in the comment section? Yes. Okay. Now here, if we are saying that this is positive, right, and this is negative, then overall it will always be positive. That means it is always going to be non-spontaneous reaction. Okay. So these are the 4 conditions that they will ask you, right? This all I have given you here, when it is positive, when it is negative. Now, this formula that I was talking about, that you, if you really want to, like, you don't want to take any risk in thermodynamics, then this is not a very big deal. Okay? I am just picking out those things which are less time consuming and more marks you can get out of it. I don't know why. I think now, because no disturbances in the class, right? Okay. So as you can see here, students, this is the only formula that you have to remember. This is the only formula that you have to remember. What if I tell you from this formula, you can make so many other formulas? Okay, so this is the general expansion. If I talk about isothermal process, eliminate T from here, eliminate T from here. So it will be NR natural log of V2 by V1, or it can also be written as NR natural log of P1 by P2. If I say that it is an isobaric process, in that case, pick out the formula where you have pressure. In the pressure case, eliminate this thing and you will have this as the answer, that is NCP ln of T2 by T1. If I talk about isochoric process, then pick out this formula and then eliminate the volume here, because V1 and V2 are equal. Then here it will be NCV natural log of T2 by T1. So from one formula, you have made 3 more formulas. That is why this question has been asked in last 2 years only. It's not like a very frequent question, but this has been asked 1 to 2 times only. But I feel that if they want to take some revenge, then they can ask you these kind of questions. Okay, so I will advise you to do this formula as well, because it is not very like long, lengthy formula, right? Okay. Chalo. Now let us do the questions of thermodynamics. Everybody, are you all ready for the test part? Now is the question part. Are you all ready for the question part? Okay. Are you all ready for the question part? Now it is the correct thermodynamic conditions for the spontaneous reaction. For the spontaneous reaction, the correct thermodynamic equation, right? That is nothing but delta G is equals to delta H minus T delta S. For spontaneous reaction, if I say delta H is negative, this is also negative. The correct thermodynamic for all temperature. You need to have it on all temperature. That means this cannot be the answer. If I say this is negative and this is equals to 0, right? Then it will always be negative, right? Okay. If I say that this is positive, this is negative, then this will always be positive. This is also not correct. If I say that this is negative and this is positive, okay, this is negative, this is positive. So now you have two conditions where delta H is negative and delta S is 0. Delta H is negative, delta S is positive. Now delta S is 0 only at absolute 0, right? So this is automatically eliminated. So answer will be D is the correct answer. Okay, D is the correct answer. Okay. Next is hydrolysis of sucrose is given by the following reaction. This is the reaction. If the equilibrium constant is this, the value of delta G at the temperature. So basically this is this formula I forgot to tell you. This formula I'll tell you in equilibrium, but let me just introduce you to this formula. That is not equilibrium. This formula is there in equilibrium also. This formula is there in electrochemistry also, right? And this formula is there in Gibbs energy also. So that's why this formula automatically becomes important to you. That is delta G is equals to minus nRT. Now here they are talking about if the equilibrium constant Kc is given to you, Kc, that means this is given to you, R value you know that is 8.314, temperature we know that is 300 Kelvin. Just put all these values here and you will get the answer as C. Okay. Next is the correct option for expansion of ideal gas under adiabatic condition. Under adiabatic, the correct option for free expansion of an ideal gas. Beta, what is free expansion? In the case of free expansion, all the things are equals to 0. That means Q is 0, delta U is 0, W is 0. That means the first law, in the first law of thermodynamics, all the terms that are there in first law of thermodynamics are going to be 0 in the free expansion, right? Next is for a reaction, they have given you a reaction. In this reaction, we have 2Cl give rise to Cl2, right? Now you have to tell what is happening here. Okay? Firstly, randomness. Two molecules are, two atoms are making one molecule. That means the randomness is decreasing here. That means the entropy is decreasing, right? Next is whether delta H is negative or positive, right? Whenever you want to, two atoms are coming closer and they are making a molecule, you require energy here. That is why energy is here negative. Okay, so here what will happen? Basically this heat will be released. This will be a exothermic process, right? Okay, so that you have to know whether it's exothermic or endothermic process. Okay, now the next important chapter is equilibrium. Let us see from equilibrium what kind of questions they can ask you. Okay, understood? Let us go through the equilibrium chapter. From equilibrium, what are the questions that they ask you? Basically, you have two parts of equilibrium. One is chemical equilibrium, other is ionic equilibrium. So firstly, I'll talk about chemical equilibrium. Okay. Firstly, I'll talk about chemical equilibrium here. Now, if you see chemical equilibrium, what all you need to know, first is what is law of mass section. It is product raised to power the stoichiometry divided by reactant raised to power the stoichiometry. If we are talking about Kc, then we will have concentration raised to power the stoichiometry of product, right? That means concentration of product raised to power stoichiometry divided by concentration of reactants raised to power the stoichiometry. If you are talking about Kp, in this case we will say the pressure of the product raised to power the stoichiometry divided by pressure of reactants raised to power the stoichiometry. In case of mole fraction, we will say the mole fraction of product raised to power stoichiometry divided by mole fraction of reactants raised to power the stoichiometry. Now, important thing here is the relation of Kp, Kc and the relation of Kp and Kx. Right? Now, most important relation is Kp and Kc from where the questions are asked. That is Kp is equals to Kc RT delta Ng. Right? This has never been asked, right? But still I am asking you to do it because you never know if they ask you something new related to what they were asking already, right? So that is why this is what they are asking. This is what they can ask in the new pattern. That is why I am also giving you some formulas of new pattern as well, right? Now here, if you talk about the units here, units will always be mole per liter delta Ng, right? Now always remember that pure liquid and pure solid, the concentration is going to be 1. Right? For pure, for example, if you talk about this reaction, this is the pure solid. So we will not take this pure solid in the equation of the Kc. Right? Because pure solid or pure liquid have concentration 1. Right? Next is the chemical equilibrium Qc and this. So now beta Qc, how you need to remember the Qc and Kc values. Qc is a reaction quotient at any temperature, right? At any time. But when we talk about equilibrium point, then Qc will be equals to Kc at that particular point, right? Now you what remember that this is your Kc, this is Qc. If Qc is greater than Kc, then the reaction would want to go backwards to become equal to Kc. That is why if Qc is greater, then the reaction will be towards the, I'm just going to write it directly here that the reaction will be backwards. Okay. Then the reaction will be backwards. If you talk about, if you have Qc less, this is Kc, this is Qc. Now what you have to do, this will increase and will become equals to Kc. That means here it will go in the forward direction. If Qc and Kc are equal, that means the reaction is at equilibrium. Okay, understood? Yes, very good. Now, last topic from chemical equilibrium from where the questions are frequently asked are Lee-Chartlier principle. Okay, so first thing is you should know the formula of law of mass section. Then what is QC-Kc? Then this Lee-Chartlier principle you should always remember, right? Now let's talk about what is Lee-Chartlier principle. I have given you the conclusion in this summary part. If you talk about the concentration, Lee-Chartlier means it is always going to behave in the opposite manner. If you say that concentration opposite, if you say that reactant we are increasing, then according to Lee-Chartlier principle, it will try to decrease the concentration of the reactant. That means opposite to the increase or decrease of the concentration, right? But it will have no effect of the solid component. If you are adding the solid component, then there will be no effect on it, right? Next is pressure. For pressure, remember, whenever you are increasing the pressure, it will go in that direction where number of moles are less. Whenever you are decreasing the pressure, it will go in that direction where number of moles are more. For example, you have NH3. So, for example, you have 2x, give rise to this is y, this is z, right? This is 2. Here number of moles, gaseous moles are 3, here number of gaseous moles are 2. When you increase the pressure, it will go in backward direction where number of moles are less. When you decrease the pressure, it will go in that direction where number of moles are more. That means in the forward direction it will go, right? Next is the volume. Volume is opposite, it will behave opposite to the pressure, right? So if here you are saying that on increasing the pressure, it is going on that direction where number of moles are less. But here, when you increase the volume, it will go in that direction where moles are more. Okay, when you decrease the volume, it will go in that direction where moles are less. Okay, so it will vary according to the reaction what it will do, right? For temperature is also very important. Beta, most important are temperature and pressure. Mostly what I have seen is they ask temperature and pressure mostly, right? In fact, every question you will see is based on pressure and temperature. Concentration, so they will not ask. Volume also they don't ask, but still you should know, right? Now here about the temperature, if the reaction is exothermic, then temperature and direction is opposite. That means if you are increasing the temperature, it will go in backward direction, right? If it is endothermic, then if you are increasing the temperature, it will go in forward direction. Okay, then that is directly proportional. This is inversely proportional. Okay, for an inert gas at constant pressure, like you have inert, you have adding inert gas at constant pressure, it will move towards where number of moles are more. At constant volume, there will be no effect. At constant pressure, it will move in that direction where number of moles are more. Last is what is exo, what is endo. Exo reactions are like Haber's process is exothermic. This SO3 formation from SO2 plus O2 is exothermic. All the combustion reactions are exothermic in nature. Endothermic are, for example, or the decomposition reaction. The formation of NO from N2 and O2, that is also endothermic in nature, right? Okay, this I have given you here because this is also asked, right? This is also very important and very easy, right? This is also asked from chemical equilibrium. That is, if you talk about the reverse, if you reverse the reaction, then the rate constant will be reverse. That will be inverse of the first one. If you multiply two reactions, then their rate constants will be, for example, no, not two reactions. For example, you are doing multiplication with some constant n. You are multiplying the reaction with constant n. Then the rate constant will be, you will put the number that you are multiplying it with in the power, and that will give you the new rate constant. If you are dividing it by some number, that will be raised to power the initial rate constant, right? If you are adding two reactions, then those rate constants will get multiplied and you will have the new rate constant. If you are subtracting two reactions, then you will have to divide first two reactions, the rate constants of first two reactions, and then you will get the rate constant of the third reaction. Okay, yes, the coefficient will go in the power. Hanji beta, tell me, is there any problem in this thing also? Is there any problem here? Any problem here? Now, talking about the ionic equilibrium, what exactly we do in ionic equilibrium? Ionic equilibrium, what are the all important formulas that they can ask you? Basically, only two formulas they ask you. One is pH, right? First question is regarding the pH, other is regarding salt hydrolysis. Okay, two questions they ask you. pH also, I have mentioned all the formulas here, but I will tell you what are the most important formulas that are frequently repeated here, right? So firstly, we have strong monoprotoic and acid. Dekho. In this case, what you have, in this case, directly you can say for strong monoprotoic acid, right? Directly you can say pH. Always remember pH is equals to minus log of H positive of that solution. Okay, so you can directly use this formula because H positive concentration will be given to you, right? But if we say that we are adding two strong monoprotic acid like HCl, H2SO4, 2 we are adding here, then their normality, that means N1V1 plus N2V2 divided by V1 plus V2, that will be the H positive concentration of the solution. After putting the H positive value here, you will get the value of pH. Talking about if you have two strong bases, then again you will add the normality multiplied by volume of both the cases divided by V1 plus V2. that will give you the OH negative concentration. From that, you can easily calculate POH value, that is equals to minus log of OH negative solution. Okay. Now, very important, either they will ask you question from this one, this one, this one, or this one. Out of this is the most favorite question. Okay, that is when you have one strong acid and one strong base. For one strong acid and strong base, you will have to see which is more. If N1V1 is more, then N1V1 minus N2V2 by V1 plus V2. If N2V2 is more, then N2V2 minus N1V1 by V1 plus V2. Important thing, if I am saying that this is for acid, and for acid your N1V1 value is more, then you are basically counting the H positive concentration. If the concentration of N2V2 is more, which is a base, then we are calculating the OH negative concentration, not H positive concentration. Okay, understood? Understood? Now this all is not important for you, so I am just deleting this page here because we are only talking about what is important for you, right? Okay. Then for salt hydrolysis, what they can ask you is the question based on these formulas, right? Directly the pH you have to note. If you have weak acid and strong base, the formula for pH is this, that is pKw, that is nothing but 14, plus pKa plus log of C, the concentration. If you have strong acid and weak base, then the formula is pH is equals to half pKw minus pKb minus log C. If you have weak acid and weak base, then the formula is pH is equals to half pKw plus pKa minus pKb. Okay, so these are the three important formulas of salt hydrolysis. In salt hydrolysis also, mostly they will ask directly the value of pH. All the things they will give in the question itself, right? Next we have is the buffer solution. From buffer solution, beta, what I am telling you is the pH formulas of all of them. Okay? Because as I told you, either the question is asked from pH, right, or the question is asked from solubility, KSP values, right? So pH of buffer is not very important, right? Mostly they will either ask you from strong acid, strong base, or from these three formulas, that is salt hydrolysis. This will be on the lowest priority if you talk about the pH value calculations, right? If you have acidic buffer, which is weak acid and it's salt with strong base. Weak acid like CH3COH. It's acid with strong base like CH3CONA. If you have acidic buffer, then the solution, the formula will become pH is equals to pK plus log of conjugate base by acid. If you talk about the basic buffer, then this will be POH is equals to, instead of pKa, you have pKb. Instead of conjugate base, you have conjugate acid. Instead of acid, you have base. That means everything that we are talking acid here will be converted into base here. Everything that is acid here will be converted into base. Whatever is base here is converted into acid. For example, here we have conjugate base, that will be conjugate acid. So these are very easily you can learn these formulas. What is basic buffer? That is weak base like NH4H. It's salt with strong base, that is NH4Cl. Okay. It's strong with strong acid. It should be acid. Okay. It's salt with strong acid. Now, this is a very, 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 very important question. If you ask me, ma'am, pH is more important or solubility is more important? Solubility is more important as compared to pH. Okay? Because here though every year they ask questions. Every year. Right? Without any break they ask questions from solubility. Right? But from ionic equilibrium we can't skip pH. Right? That is also very important. But yes, if you talk about the trend, they are asking questions from solubility and solubility product. Simple thing here, what you have to note down is, if you have X, let's say XA plus YB, then the answer of KSP will be x raised to power x, y raised to power y, solubility of x plus y. That is the trick. Okay, x raised to power x, y raised to power y, solubility of x plus y. That is going to be the trick here. Understood? Yes? Okay. Chalo. This you don't need to do. You can skip this. Right? Now let us do some questions based on the equilibrium. Right? Okay. Let us see what kind of questions previous year they are asking you from equilibrium. Okay, students, let us see that. Okay. Chalo. If you see this here, if the value of equilibrium constant for a particular reaction is this, then at equilibrium the system will contain. They are saying the equilibrium constant value is greater than 10 raised to power 10. Similar amount of reactant and product, all reactant, mostly products. So if your Kc value is greater than 10 raised to power 3, right, then we say it is like more products are formed. It is favoring the forward direction. So it is mostly you will see the products here. That is based on the law of mass section. If your Kc is more, that means product value is more. Okay, so answer will be mostly you will see products. Then next is a liter container, a 20-liter container at 400 Kelvin contains CO2 at pressure, this, and excess of CRO. Then the volume of container is now decreased by moving movable piston fitted in the container. The maximum volume of the container when pressure of this attain its maximum will be. Chalo, let us try to solve this question, everybody. Let me see if the next question is based on. Chalo, firstly, I'll solve the next question here. That is based on Lee-Chartlier principle. Okay? Acha. Which one of the following conditions will favor maximum formation of product? This is based on Lee-Chartlier principle. Can you tell me what is this? Which one of the following condition will favor maximum formation of product? Now, as you can see, this is an exothermic reaction. Okay? Temperature and K are inversely proportional. If you want to have forward direction, then temperature should be low here, right? If temperature is low, then it will favor the forward direction, right? If you talk about pressure, here you have 2 moles, here you have 1 mole, right? So if you want to have forward, that means less number of moles. If you want the direction to go in less number of moles, in this direction it is only possible if you have high pressure. So that means low temperature and high pressure are favored here. Okay. Okay, ji. Chalo. Now let us see this numerical. Let us see where is this numerical. It is here. Okay. Chalo. I'll just solve this here for you. So basically what they are saying here, they have given us this equation that is already given to us. Okay, this equation is given to us, Kp is given to us. A 20-liter container at 400 Kelvin contains CO2 at pressure this, right? That means it contains CO2 at 0.4 atmospheric and excess of C. I think this is not based on the concept that I have told you. This is more, I would say, this is not exactly the concept that I have taught you, but if you want to do it, then I can teach you this. Okay? This is not a direct question. This is slightly twisted question, but if you want me to do that for you, I can do that. Right? Okay. So first thing is, it should be CO2 here, right? 20 liter of container, the total volume of the container is given to be 20 liter, contains CO2 at this pressure, CO2 at this pressure and excess of CRO, neglect the volume of CRO. Okay. The volume of container is now decreased by moving movable piston. We are decreasing the volume. The maximum volume of the container when pressure of CO2 attains, this will be. Okay. So here what you have to do, maximum pressure of CO2 is equals to pressure of CO2 at equilibrium, right? Because we are neglecting the volume of this pressure of this CRO. That is why maximum pressure of CO2 will be equals to pressure of CO2 at equilibrium, right? So this is the equation that you have. If you talk about the Kp value, this is solid, this is solid. So Kp will be equals to the pressure of CO2 because that is product raised to power the stoichiometry. Pressure of CO2 is given in the question, that is 1.6. Okay, that is given, they have given it here somewhere. It was, so they have given when the pressure of CO2 maximum volume, when pressure of CO2 attains its maximum value will be, that means Kp is given to be 1.6. If Kp is given to be 1/6, that is maximum pressure of CO2 is also going to be 1.6. Here we are putting the value of Kp, that is 1.6. If Kp is 1.6, then the maximum pressure is also going to be 1.6 only. Now, putting this formula, V is equals to nRT by P. Here you can easily calculate the volume. Since container is sealed and reaction was not earlier at equilibrium, so N is constant, number of moles we can say is constant. So N is equals to PV is equals to RT. Okay. Now before attaining this pressure, this was having 0.4 pressure. Okay. This we have put here 0.4. The volume they have given us is 20 liters. I have put the volume, that is 20 liters. R is given to me in the question itself, and temperature also they are giving us, that is 400 Kelvin, right? So now we will just equate these two things here, putting the equation 2 in equation 1. This is the value of N. I'll just put it here. Now what will happen? If you put it here, this is 0.4 into 20 by RT. RT and RT will cancel each other and the answer will be 5 liters. Okay, got it? So this is basically after attaining equilibrium. This is before. The values are given to you. The value of pressure and volume are given to you. R and T also you can put, but there is no need to put because eventually they are going to cancel each other. Okay. This value, this is very important step, that Kp is equals to P of CO2 from the reaction, right? Because Kp is already given to you, that is 1.6. So pressure of CO2 will be 1.6 here. Okay, understood? Chalo. Now let us talk about the next chapter, that is electrochemistry, right? From electrochemistry, what are the important parts? Let us see that. From electrochemistry, what are the important parts? Yes, everybody, from electrochemistry, what is the important part? Anybody? So one important thing from electrochemistry is Nernst equation. Nernst equation, the relations of Nernst equation. Second important thing is conductance based on conductivity formulas. This includes everything: Coriolis law, the value of molar conductivity at infinite, value of molar conductivity at concentration C, and the degree of dissociation. Everything is there in conductivity. From these two topics, the questions are frequently asked in your NEET exam. So let us go through them once. Okay, let us go through them once. So first is a very simple thing, that is what is cell potential. That is nothing but very, very important. E naught of cell equals to E naught of cathode minus E naught of anode. And both of them should be the reduction potentials. Okay, both of them should be the reduction potentials. So before having the formula of relations, you should know one thing, that in Nernst equation, what is the formula of Nernst equation? This is the Nernst equation. Okay, Q you can also write it as oxidation concentration by reduction concentration. Okay, or you can also say product by reactant. So this is E is equals to E naught minus 0.059 by N. N is the N factor here. E naught cell is E naught cathode minus E naught anode, the reduction potentials. And this oxidation by reduction, we can see this from the numerical as well, right? If you have any formula, the one that is on anode side is oxidation, the one that is on cathode side is the reduction. This is on the cathode side. Okay, the ions on anode and cathode side raised to the power the stoichiometry coefficient. Okay, understood? So that is the Nernst equation. If you talk about the relation of delta G and E naught, very, very important. That is delta G is equals to minus NF E naught cell, right? So basically here F is nothing but 1 Faraday, that is 96500. N is nothing but this is N factor, that means number of electron lost or gained in that reaction. Okay, so this also is a very important formula, right? Then there is this formula, the third formula from related to this Nernst only, that is E naught is equals to point this log K equilibrium. The relation of E naught and K equilibrium, this also has been frequently asked. Either they will ask you question on based on this or this or this. And there is one more added question that nowadays we can see, that is based on this formula only. I'll just tell you what is that question. Okay? You will see from any of these four formulas, you will definitely see one question in the exam. From any of these four formulas, either it can be Nernst equation or the formula of delta G and E naught. And there is one more formula that is based on conservation of the, or you can say additive nature of Gibbs free energy. That Gibbs free energy, if you have a relation that say you have A to A positive, then A positive to A2 positive or something, this is directly going to A2 positive. Let's say this is 1, this is 2, and this is 3. So the Gibbs free energy of third is equals to Gibbs free energy of 1 plus Gibbs free energy of 2. Putting the values here, what you will get, minus and Faraday will cancel out. This will be minus and Faraday will cancel out. This will be N3 E, this will be naught, naught and naught. This will be E naught cell, or you can just say E naught 3 is equals to N1 E naught 1 plus N2 E naught 2. This is also a very important formula, from where in last 2 years we can see they are asking the question, and I don't know, I have a very strong feeling that they will ask you question from this formula. I have a very strong feeling that they will, in 2025, they will not use this, they will not use this, they will not use this. Instead, they will use formula this one. Because all are related to each other. If someone has gone through the formula of Nernst equation, they should know this also, they should know this also, they should know this formula also. Right? That all of them comes under Nernst equation formulas only. Right? Okay? Understood? Any problem here? Any problem? Understood na beta? Chal. Now next is resistance and conductance. Okay, next is resistance and conductance. So if you talk about resistance and conductance here, R is equals to rho L by A. This is the first formula that you should remember. R is resistance, rho is resistivity, L is area, L is length, A is area. One more formula that you should remember is G into G star is equals to kappa, where kappa is nothing but it is 1 by resistivity, that is conductivity. G is nothing but it is 1 by R, that is conductance. Okay, opposite of resistance, that is conductance. What is G star? That is nothing but it is L by A, that is cell constant. That is nothing but it is called cell constant. And from this formula, G into G star is equals to kappa, also they ask so many questions. This formula is not asked, this formula is asked. Okay, this formula is asked. But if you want to know this formula, you should know this formula as well. Right? Then next what they ask you is this, also we have done now. Right? Then they can ask you based on the molar conductivity, that is 1000 into kappa by molarity. and equivalent conductivity is 1000 into kappa by normality. Now here important point to note down, that if you talk about the value of degree of dissociation, chalo, that I'll do in the next part, because you should also know Corlosh law for that. So if they ask you molar conductivity at any conductance C, that will be 1000 into kappa by molarity. But the condition is the kappa should be in centimeters, right? It should not be in meters. It should not have meters in the formula, right? Now next is on dilution. We have two, from this graph also they can ask you the question. Two graphs we can draw. This is the graph for weak electrolyte. This is the graph for strong electrolyte. In strong electrolyte, you can find the value of infinite dilution. At infinite dilution, what is the molar conductivity? But for weak electrolyte, you cannot find the value of infinite dilution, right? Where is the infinite dilution molar conductivity value? For that, you have to use Corlosh law. That says that the molar conductivity at infinite dilution is equal to the individual ion molar conductivity, right? For example, you have Al2SO4 thrice. So this will be equals to 2Al3 positive plus 3SO4 2 negative. So this will be equals to 2 into infinite dilution molar conductivity of Al3 positive plus 3 into molar conductivity at infinite dilution for SO4 2 negative. That is called Corlosh law. Now, if you see this here, let's use the application. What is the application? How to use Corlosh law? Because they can ask you one question of degree of dissociation that you can only solve if you know Corlosh law, if you know the molar conductivity at concentration C. Okay? Because degree of dissociation is equals to molar conductivity at C divided by molar conductivity at infinite dilution. So that's why this will be calculated from kappa into 1000 divided by molarity. This will be calculated from Corlosh law. So you should know both the things, right? So here, molar conductivity at infinite dilution, how you will solve this in the question. For example, they are asking you for CH3COH. This is made up of CH3COO negative plus H positive, right? So here what you will use, this, that means this first should be added. If I say this is 1, this is 2, this is 3. I need to have this sign, so I'll add 1. I need also have H, so I will add 2 into this. Sorry, I'll add, this is third, na? To third, I'll add 1. And then I'll subtract Cl and Na from here by subtracting the second one. So this will be my answer. That is third plus first minus of NaCl. That is going to give me my answer for infinite dilution for the weak electrolyte, which you will put here, and hence you will get the value of degree of dissociation. This you will get from molarity. This you will get from the formula of kappa into 1000 by molarity. This you will get from Corlosh law. Okay. After solving this, you can easily say what is the degree of dissociation, what is the dissociation constant, that is C alpha square. Okay. Understood? Beta, any problem here? This all we have done already. Okay, ji? Sure. Tell me, beta, any problem here? Any problem here? Any problem here? Hanji, students, any problem here? Let me just see. Yes. So molar conductivity, do you want to do the questions based on molar conductivity now? Do you want to do the questions based on molar conductivity? Yes, ma'am, no problem. Everything is clear. All sorted. Very good. Now let us do some questions now. If you all are ready. J means after listening to classes, and we are such grateful for your hard work. Ma'am, my mother is big fan of you, ma'am. Thank you so much, Dream. Thank you so much. That means the world to me. And thank you so much for all the appreciation that you give me. Thank you. Okay. Huh. Let us do the questions now. Ready? Chalo. The molar conductivity of 0.007 molar acetic acid, okay, this is the concentration is 20, okay, that is given to you. What is the dissociation constant of acetic acid? See, for molar conductivity at infinite dilution, you have to add this, so this will be 350 plus 50, that is going to be 400. Molar conductivity at infinite at a concentration C is given to be 20. Okay, that is given to be 20. Right? Here what you will do, alpha will be equals to 20 by 400. 0, 0 cut, this will be 1 by 20. Right? K is equals to C alpha square. That means what is C? C is 0.007 multiplied by 1 by 20 square. So you can easily calculate the value here, isn't it? Okay. Okay, got it? So you can easily see this. This is C alpha square. Alpha you have already calculated from here. Alpha is, what is the value of alpha? What is the value of alpha? Molar conductivity at C, molar conductivity at infinite dilution. Okay, infinite dilution they have given us. C they have already given us. Right? Isn't it? So easily you can calculate this. The answer is going to be 1.75. So answer will be A is the correct answer. Next is So next question is based on the Nernst equation here. The pressure of H2. This is also a very important question. Okay. This is also a very important question because students usually skip this, that okay, this is not. Thank you, Nandu, thank you. So here it is, the pressure of H2 required to make potential of H2 electrode 0 in pure water. Right? So what you have here is the pressure of H2 required, right, to make potential of H2 electrode 0 in pure water. You have pure water here. Right? So what you have to do is that you have the reaction is 2H positive plus 2 electron it will gain, this will be H2. Right? The pressure of H2 required, we need to see what is the pressure of H2 that is required. In pure water, the concentration of each of them is going to be 10 raised to power 7. It's a very important question, okay? So, in pure water, the concentration of H positive and OH negative is always 10 raised to power minus 7. Right? This is the constant thing. Now we know that if you apply this particular formula in Nernst equation, it will be E is equals to E naught minus 0.059 by Y in factor is 2 because 2 electrons you are gaining here. Log of product by reactant. So product is pressure of H2, reactant is H positive raised to power 2. Okay, this should be H positive raised to power 2 because this is H positive, stoichiometry is 2. The concentration of H positive is 10 raised to power minus 7. N factor is 2 or E naught is given to us as 0 to make the potential as 0. So this is 0 that is given to us. This is also 0. So if you solve this, what you will get? Okay, E is also 0. You solve this, you will get log of pH2 by H positive square is equals to 0, which is only possible. But the log of which value is 0? If you have, which is only possible, if pH2 divided by H positive raised to power 2 is equals to 1. Because log of 1 is equals to 0. Okay, if you have log of something is 0, that means that thing is called as 1. So this pH2 divided by H positive concentration raised to power 2 is equals to 1. So here answer will be pH2 is equals to 10 raised to power, this is 2. So this is 10 raised to power minus 14 only, right? Okay, so that means pH2 is going to be 10 raised to power minus 14. That is B is the correct answer. Is that clear to everybody? Is that clear to everybody or not? Ma'am, the question is not clear. Okay. Are you not able to see it or anything? The pressure of H2 required. They are saying the pressure of H2. You have to make H2 to make potential of H2 electrode as 0. That means this potential you have to make it as 0. E naught value, that is standard hydrogen electrode potential, is always taken as 0 conventionally only. Right? So you just have to apply the Nernst equation. E is equals to E naught minus 0.059 divided by n factor log of product by reactant. Because now this is the reaction. So product is pH2, product is pressure of H2. In reactant side, you only have ions. So it will be H positive raised to power 2. Okay, got it? Okay, understood? Abhi, you understood? What we did here, it's a very important question. Chalo. Now, next is chemical kinetics. Okay, next is chemical kinetics. In chemical kinetics, what you have to do, let us talk about that. Okay, ji? In chemical kinetics, what you have to do, let us talk about that. So, chemical kinetic, anybody, what is the most important thing in chemical kinetics? From chemical kinetics, from where the question are asked? Chemical kinetics, the questions are usually asked on first order reaction or T half or units of K. These are the things that we are going to focus on. These are the things that we are going to focus on. These three small topics. Right? Okay, yes. First order reaction is very important. Okay. So zero order reaction, this I have aise hi written here, right? But I am going to focus on first order reaction here. Zero order reaction, this is the formula. That is, if you say this is AT is equals to A naught minus KT. This will be the formula. And here T half is equals to A naught by 2K. Okay? These things are important. You should know the zero order reaction formulas. Okay? Remember one more thing here, that generally, I'm writing here, I'm writing on this page, generally the general formulas here, generally T half is directly proportional to A naught initial concentration 1 minus N, right? And K is equals to mole per liter 1 minus N per second. That is the general formula of rate of units of K, where N is the order of reaction. N is the order of the reaction. These two formulas are general. Sometimes they directly ask you the relation of T half with any order of the reaction or the units of K, that is rate constant, for any of the orders, right? So for that, general formulas are important for you, right? Then let us jump to the first order reaction, which is most important. This is the general formula. General formula, the way I write it is T is equals to 2.303 divided by K log of initial concentration by final concentration. To solve the numerical based on this particular formula, you need to know two things here. What are the two things that you need to know? See, if they have given you in terms of percentage, if they have given you in terms of fraction. Okay? Very important two simple things I'll be telling you here. If they have given you this in terms of percentage, right? Let's say they have given 70% of the reactant is consumed, 20% of the reaction is left, anything like that. You will always take initial concentration as 100%. If they say 70% is consumed, if you say this percentage is consumed, then final will be Y% consumed. Y% consumed. If they say this much percentage is left, consumed means, if they say, I'll just write it here in this way, Y is consumed, Y% is consumed, right? Or if they write X percentage is left behind. Similarly, here also we will do the same thing. If they say Y is consumed, that means AT is going to be 100 minus Y, right? Okay. Now, if they say X percentage is left, then AT is going to be X. Okay, whatever is given to you in the question. Now, if this is given in the fraction form, then you will always take A naught as 1. Now, if they say, let's say Y is consumed in the form of fraction only, they say 3 by 4th is consumed, 1 by 2nd is consumed, something like that, or X is left behind. So, whenever they say this much is consumed, so 80 will be equals to not 100, 1 minus Y. This will be equals to 80 is equals to X. Tell me, is this thing clear to everybody or not? If this thing is clear to you, then you will have no problem in solving the numericals of first order reaction. Okay? The main problem is not learning the formula. Formula everyone knows. We just get confused in when initial concentration is not given, then what to take. If things are given in percentage, take initial as 100. If it is given in fraction, take initial as 1. Okay? Is that clear? Is that clear? Is that clear? Is that clear? For nth order, this is generally I have written it here. If you want to skip it, you can skip it. Okay, generally I have written it here. Right? Then the second concept here is very, very important. First concept was first order reaction. Okay, from the first order reaction, numericals are asked. Second most important thing is Arrhenius equation. Okay, from here the questions are asked. So Arrhenius equation is nothing but K. A is Arrhenius constant, E raised to power minus EA RT. EA is the activation energy. This should be EA by RT. Okay. If you solve this, you will get this particular formula, right? From this formula, numericals are asked. From this formula, usually numericals are asked. From this, usually graph are asked. Okay. So from numericals, what they can give you the value of T1, T2. They can give you the value of K1 and K2. They can ask you what is the answer for activation energy, that is EA. Directly apply this formula, you will get your answer. If they give you the graphical question here, then what you have to do, we know that K is equals to A e raised to power minus EA by RT. When you take the natural log here, you will get this formula, right? If you compare this with Y is equals to, this is mx, this is C. So now here we can say, if this is y-axis, that is ln k, this is the y-axis. X-axis is, let's say, 1 by t is the x-axis, 1 by t is x-axis. Then slope will be is equals to minus EA by R. That will be your slope, and this is going to be your intercept. That is going to be your intercept. Intercept is going to be natural log of A. Got it? So this question is also, this so they have asked in 2024 only. This question was exactly there in 2024. Right? So very simple question they ask from here. Chalo. Now let us see some question from chemical kinetics. After that, we are going to do solution chapters. Are, what is happening? Board is tired or what? Okay. Now, let us see some questions from chemical kinetics here, right? Let us see some questions from chemical kinetics, everybody. Are you all ready for chemical kinetics or not? Ready for chemical kinetics or not? Chalo. Let us do the questions from chemical kinetics. After that, we are going to do solution chapter from where one topic which is very important, right? For sure, we will see question based on that topic only in the exam, right? Okay. So after that, our physical chemistry will be done. Then we will be left with only organic chemistry. Okay. Understood? Chal. Everybody, yes. Everybody here. The rate constant for the first order reaction is 4.6 into 10 raised power minus 3. The time required to reduce 2 gram of the reactant to 0.3. This is the initial, this is the final. Okay. So rate constant for the first order reaction they are saying is this. K is given to you. Time required they are asking. So just put the formula. Okay, just put this formula. T is equals to 2.303 divided by K log of initial is what? Initial is given to be 2, final is given to be 0.2, that will be 2 into 10, right? K is given to you, that is 4.606 into 10 raised power minus 3. This will be cut to 2, so this will be 0.5 into 10 raised power minus 10 raised power 3, and this log 10 will be equals to 1. So answer will be 500 seconds. So answer is A is the correct answer. Okay, so this question is directly from first law. First law I am saying this question is directly from first order kinetics. Then there is one question that I told you based on Arrhenius equation. Okay, how they will ask you question based on Arrhenius equation? It says that the slope of Arrhenius plot when you have natural log of k versus 1 by t. We know that if you have this thing that is equals to natural log of k, c, this is equals to minus Ea by r, and this is 1 by t. So if you are considering this as y, this as x, then this will be your intercept and this is your slope. So slope means minus Ea by r is equals to minus 5 into 10 raised to power 3. Okay? The value of E for the reaction is choose the correct option. So E will be equals to 5 into 10 raised to power 3 multiplied by R. R is given to be 8.314, right? Joule per Kelvin per mole. So you just need to solve this value and you will get your answer. So basically this is a question from graph only, but slightly they have given you the value so that you can also do the calculation work here, right? So based on graph also the questions are asked. Next is the rate of first order reaction is 0.04 mole per liter per second. Okay, at 10 seconds. Okay, the rate of first order reaction. Now they are saying the rate of first order reaction. What they are saying, beta, here? Till here everything is clear, no? Till here everything is clear, na? First two questions based on first order and Arrhenius equation. Now, let us try to solve this question. Try to solve it by yourself. Rate of first order reaction is this at 10 seconds and this at 20 seconds after initiation of the reaction, the half-life period of the reaction. Half-life period they are saying. Okay? They have given you two rates, two times. This is a very, very important question where this formula will be applied. Okay? This might be a new formula to you where you have rate constant is equals to, if you have two times and they have given you two values of rates, then what you have to do? This you can just directly write the value of rate. This you can write R1, this you can write R2. Totally your choice. Directly also you can write it. So this will be T2 minus T1, 20 minus 10, R2 divided by R1 by R2. You can put the value of R1 0.04, R2 as 0.03. Put the values, you will get your answer. Got it? Now, this to beta we have calculated the value of K. They are asking you the half-life period. For first order reaction, half-life period, what is the value? Is this a first order reaction? Yes. So directly you can tell the half-life period is equals to 0.693 divided by K. If K you have already calculated, just put the value of K here, right? Okay, this is the value of K and half-life will be 0.693 divided by the value of K. That is going to be your answer for T half. Okay, ji, that is going to be your answer for T half. I can see you guys are not that much interested, है ना? Not that much interested. Chalo, no issues. Then I'll think that I should do organic today or not. Because I can see the interest in the chat box. It's such a boring chat you are making it. Ma'am, your studio got stuck, then we will show no energy. है ना? So that is very, very disappointing on your point. Very disappointing. Chalo. Now, the addition of catalyst during chemical reaction alters which of the following quantities? So, whenever you are adding the catalyst, which quantities will get altered? Activation energy. The path of the reactant will get changed. Earlier, this was the path. Now, the path of the reaction will get altered. That means earlier this was the activation energy. Now, this will be the activation energy. Right? Okay. Now, physical chemistry, solution chapters, any idea from where the questions are asked? Questions are asked from colligative property. So, I am picking out the concept of colligative properties from solution chapter. Okay, I am picking out the concept of colligative property from solution chapter from where the questions are asked. So basically you have 4 colligative properties from where the questions are asked. Okay, 4 colligative properties from where the questions are asked. Okay, let us see that. Okay, everybody. Okay, what are the 4 colligative properties? What are the 4 colligative properties? I think I need to wake you up from the sleep. What are the 4 colligative properties that you have? First colligative property is the vapor pressure. Okay? So basically what happens whenever you add non-volatile solute into the solvent, right? Vapor pressure decreases because you have added a solute which is not making the vapors. So earlier if vapors were supposed to be 100, now because you have added non-volatile solute. Okay, so for example, this was the beaker, you had solvent particles here. So when you are adding solute which is non-volatile, which is not making the vapors, so your vapor pressure is going to get decreased here. Right, so vapor pressure will decrease. So what you can see here, vapor pressure decreases. First thing, right, that is vapor pressure will decrease. What is the second thing that you should know here? Vapor pressure will get decreased. Second, vapor pressure decrease means relative lowering in vapor pressure. What is the formula of relative lowering in vapor pressure? Pure vapor pressure divided by pure minus the lowered vapor pressure. P naught minus, wait a minute, relative lowering, na? This will be P naught minus P divided by P, right, is equals to mole fraction of the solute, right? Okay. Second colligative property is boiling point. So in boiling point, you tell me what will happen. In boiling point, beta, you tell me what will happen. Elevation. Can you tell me why the boiling point will get elevated? See, boiling point is when vapor pressure will match the when the vapor pressure will match the atmospheric pressure. So when your vapor pressure is going to get equal to the atmospheric pressure, that is called the vapor pressure. That is called the boiling point. So if this is your vapor pressure, this is the atmospheric pressure, when they will become equal, then you can say that yes, I can say that here boiling point has achieved. If this is the vapor pressure of pure solvent, this is the atmospheric pressure. Vapor pressure initially is this of pure solvent. Then this is the boiling point, right? Now vapor pressure has decreased. Now this is the boiling point. That is why we say there is elevation in the boiling point. Elevation in boiling point, right? Which is delta TB is equals to MKB, right? MKB. Third is freezing point, and here freezing point is decreased. Depression in freezing point. Any idea that why freezing point will get decreased? Any idea, students, why there is decrease in the freezing point? Any idea about it? So basically, if you talk about the depression in the freezing point, this is the here freezing point does not mean we should equate it with the atmospheric pressure. No. Here, if your vapor pressure of the liquid is equals to the vapor pressure of the solid state of that solvent, then that is called freezing point. If I say this is the vapor pressure of the liquid, okay, vapor pressure of liquid is more or vapor pressure of solid state is more? Definitely liquid forms more vapors. So this is the vapor pressure of the solid, which is fixed. Vapor pressure of the solid. Now, initially this was the freezing point, right? Now, when I am adding the non-volatile solute, the vapor pressure of the liquid will decrease. Now, this is the vapor pressure of the liquid. Now, this is the freezing point of the solution. That is why here you can see the gap has decreased. That is why this is called depression in freezing point. Because this is the easiest way that I can tell you what is depression of the freezing point. Okay. So, formula is same. Delta TF is equals to M into KF. Right. The formula is same. Got it? Okay. Chalo. Next is fourth. What is the fourth formula here? What is the fourth colligative property? Anybody? Fourth colligative property is osmotic pressure. Osmotic pressure. Fourth colligative property is osmotic pressure. So any idea about it? In osmotic pressure, what you have to do? In osmotic pressure, pi is called the osmotic pressure, right? That is equals to CRT. What is C? C is nothing but it is molarity, not molality. This M is molality, this C is molarity, right? So here it is number of moles by volume, that should be in liters, into RT. That is going to be the formula of osmotic pressure. Now, whenever you have Van 't Hoff factor, when you want to add Van 't Hoff factor, that will be over here, right? What is Van 't Hoff factor? If you have an electrolyte, like if you have urea, sucrose, glucose, these are non-electrolytes. So there is Van 't Hoff factor will be equals to 1 because there is no association or dissociation. In case of electrolytes, there will be association, there will be dissociation. Because of that, there will be one more factor that will be added, that is Van 't Hoff factor. Like NaCl, if it is having 100% dissociation, the Van 't Hoff factor is going to be 2. Right? Okay? Understood? Yes, everybody? Chalo. Now let us do some questions based on this. After that, I would want to know from you as well if you want to do organic chemistry today, or if you want me to take up one more lecture which is totally on organic chemistry. Okay? Then I'll take one more lecture because concepts, so I have taken more than 30-40 concepts I have taken, right? Around 30 concepts I have easily taken, right? Now, if you have the energy, then I can do this organic chemistry because that will take me another 2 hours, right? If you want one more lecture, right, for different lecture for organic chemistry, then I'll take different lecture for organic chemistry. Okay? Okay? Chalo. Now, let us see the freezing point depression constant, that is freezing point depression constant of benzene is 512. Freezing point depression constant means they are talking about Kf here, right? The freezing point depression for the solution of molality, this molality is given to you containing a non-electrolyte in benzene. Non-electrolyte means you Van 't Hoff factor is 1 only, is up to this. So now what you have to do, delta TF is equals to molality into Kf. Molality is given, this is given. They are saying the freezing point depression for the solution of molality, this they are asking you the depression. That means what is the value of delta Tf? So that is nothing but that is equals to bond Hall factor. I told you it is 1 only for non-electrolyte, right? Kf is given to you, that is 5.12. Molality is given to you, that is 0.078. Now, what if the molality is not given? Then what you will use? Molality is equals to number of moles of solute, that is W2 by M2 multiplied by weight of solvent, that is W1 multiplied by 1000 here. That is going to be the value of molality. Okay? Yes. Okay, that is going to be the value of molality. Got it? Okay. Next question is, at 100 degrees, the vapor pressure. Now we are saying at 100 degrees, the vapor pressure of the solution of 6.5 gram of solute in 100 gram water is 732 millimeters. Not millimeters, mm. This is not millimeters, this is mm of Hg. Right? Now at 100 degrees Celsius, the vapor pressure of the solution is 6.5. Of 6.5 of solute, that means W2 is given to you. Here what is given? W2 is given to you. Okay? 2 always represents solute. 1 always represents solvent. Always remember this whenever you are doing the formulas, you are doing this questions of solution chapter. 2 represents solute, 1 will always represent solvent, right? So here it is, at 100 degrees Celsius, the vapor pressure of solution of 6.5 gram of solute in 100 gram water. Now 100 gram water is nothing but this is weight of the solvent, that is W1, right? The vapor pressure of solution, that means for the solution, that means P, vapor pressure is given to you, right? If Kb is this the boiling, if Kb is this the boiling point, I think the boiling point of what they are asking, I think the question is incomplete. The boiling point take place, I think they are asking you the value of, they are asking you the value of new boiling point of solution. This is what they are asking. Okay? Now what we will do here, what we will do here, we know the value of, let's say, at this the vapor pressure of this much of solute in this much of water. Beta see, we know the weight of solute, we know the molar mass. I'll just write it according to myself. So this is basically W2, this is M2, this is W1, this is M1. Okay, so we know the value of W2, we know the value of W1, we know the value of M1, that is the water, that is 18. Okay, this is the molar mass of the water, of the solvent, that is 18. Weight of solvent is given, weight of solute is given. We don't know the molar mass of the solute. Okay, always and always the vapor pressure of pure solvent, solute is going to be 730. Okay, so that is 730 minus 732, that is your vapor pressure of the solution, right? Answer you will get out of it, that is molar mass will be 32. Okay, once you get the value of molar mass here, what you will do here, once you get the value of molar mass here, right, on solving molar mass you will get, now we know that delta TB is equals to I into Kb into M, right? Kb is already given to you, that is 0.52. They are telling us nothing about the solute, nothing about this, that means Van Hoff factor will be 1 only. So I'll take Van Hoff factor as 1. If nothing is given, then also take Van Hoff factor as 1. Molality is nothing, that is molality, what we will take, W2 by M2 multiplied by M1, multiplied by W1 multiplied by 1000. This we have calculated the value of M2, this we know, this is given to us, W1 we know. Okay? So we'll put all the values here, right? We will get the value of delta TB here. Okay? Till now, we have calculated the value of elevation, the difference, that is delta TB. We don't know what is the value. What they are asking you is the value of boiling point of solution. That means they are asking you TB here. Okay? So we know that delta TB is equals to larger minus smaller because the temperature has increased. So that is why it will be boiling point of solution minus boiling point of pure solute. Okay? Pure solvent. Right? Now, we know that the boiling point of water is always 100 degrees Celsius. This we have got to know that the value of delta TB, which is coming out to be 1, is it? Yes, it is coming out to be 1. Right? So the value of TB is going to be 100 plus 1, that is 101. So answer is going to be B is the correct answer. That is the boiling point of new solution that you have made here. Okay? Okay. Got it, beta? Tell me. Is that clear? So this was also a very important question. We made the use of two things here. One is boiling point, other is the formula for relative lowering in vapor pressure. Okay? Next, so beta, it's all about organic. Everything after this is organic, 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 organic. Right? I तो genuinely feel, I don't want to know in the comments that what you want. Okay? I feel that organic chemistry we should do in the next class because that itself is very important, right? What my idea is, if you are okay with that, if you also feel the same, है ना? Because the students will also feel the same that I am feeling. Okay? So what I feel, Sukhmeet is saying let's do it today, but what I feel, instead of that, what we can do, we can make a separate thing about or separate day for organic, or we can start doing the organic. Let's say firstly we will do GOC, then we will do isomerism, right? We can do the big marathon lectures, quick marathon lectures for revision of organic chemistry. Okay? Anything like that, I am thinking about it, right? So you tell me what exactly you want, right? Right now you tell me if you want organic chemistry different lecture or today only. Okay? Because today full organic chemistry, so it's not possible. Little bit of organic chemistry I can teach you, right? That means GOC, inductive effect, all these things we can do. Okay? Helps me a lot. Thank you so much. Thank you, Malika. Thank you so much, beta. Thank you so much. Okay. Yes, ma'am. This is also nice. No, ma'am. We want another session for organic, ma'am. Malesh is saying that. What about other, ma'am? Your wish. I to feel that organic chemistry should be done when you have fresh mind, right? That is my thinking regarding organic chemistry, because for all the students who are exhausted right now, it will be very tough to you understand only organic chemistry, right? Okay, so we can do that separately as well. Okay, chalo. Then I will make, today I'll think about it on my Telegram channel and also on Vedantu NEET English. I will give you a poll regarding organic chemistry. Okay, 2-3 ideas I have in my mind regarding organic chemistry. We can do those kind of sessions for organic chemistry. You tell me what you want me to do. According to that, I'll pursue that, and then we will rock it in organic chemistry also, because what I have seen before I went on leave, we had done inorganic chemistry division, we have done physical chemistry division, but we have not done organic chemistry division. है ना? So that is what I feel is left on my part, right? So that I should do, that I feel we should do, right? Okay, so let's see. We will do that definitely. I have some ideas in my mind. We will do that. But one more thing, students, regarding your NEET is that we have a crash course for all of you. And what is that crash course, right? We all know that very less time you have for NEET. So for that, we have crash course. The timing of crash course I'll tell you. But before that, what exactly we are teaching in that crash course is the live doubt solving will be there. Live classes we have. In the class itself, if you have any doubt, you can ask. right? There you will have class teacher as well, right? Then you have quizzes, then you have previous year question discussions as well. 100 plus live sessions by the master teachers. Teachers' notes will be provided to you. Assignments will be given. Class recordings will be there. Like today, I was not able to do those many questions, right? But in batch, for one single chapter, you have full dedicated lectures where we do the questions. Okay. Then part and full test on latest pattern. You will get all these things. You will get AITS All India Test Series here, right? Where total you will get 22 tests, okay, for All India Test Series, right? Then you will get instant doubt as well. You will get access to that. For example, your doubt will be solved in just 7 minutes, right? If you have any doubt, you're doing the revision, you have any doubt, you can ask that on the doubt solve. Next is QR codes will be provided to you. In these QR codes, basically what you have is short notes, right? They are formed in a very colorful manner where all the important formulas, important reactions, important names of bio, right? And with the mnemonics are mentioned in these QR notes, and you will find it very interesting. It will be a very good revision thing for you, right? Even in this 1 month, you can take use of these QR codes, right? So whatever you need in this 1 month, we are giving you, right? Now here, batch has already started from 17th of March. The timings are morning 10 a.m. to 1:30 p.m. you have bio class. After that, you can take rest. By rest, I mean you will do assignments, DPPs, questions will be provided to you, everything you will do. Then you will have 6:30 to 10 p.m. you have your next two classes of chemistry and physics. Got it? Okay. Next, students, we have three. Basically, if you want to get all the things, that is, you want to get the batch, also you want to get VBuddy, online test and practice, you also want to get at home printed NEET QR codes, you also want to get AITS All India Test Series, and also Doubt app, then that is NEET Crash Pro, that is for 6499. Okay, so that is the best batch where you're getting everything. You are getting QR codes also, cards also, you are getting AITS also, you are getting Doubt app facility also. But if you're like, ma'am, I have already purchased AITS, ma'am, I already have the Doubt app access, or ma'am, I have someone in my locality only, some teacher who can guide me, who can, solve the problems, then that is fine. Then you can go for NEET Crash combo, right? But if you think that, ma'am, I also have purchased QR cards, ma'am, right? Then go for NEET Crash. But better, if you have not purchased QR cards, if you have not purchased AITS, then go for NEET Crash Pro only. Okay, then go for the last one. Why? Because that will be more beneficial for you. Revision is important, but doubt solving is also important, and test series is important because you should know what kind of questions will be there. Then QR cards, which will be like your summary for all the chapters, right? All the important points that you need to have in your mind will be there in the QR card, so that also should be purchased. Okay, chalo. Okay then. Yes. Okay then, students, now I will take your leave. The session has already completed. Now I'll ask you in the comment section also. I want you guys to comment down below what exactly you want for organic chemistry. Okay. Comment down below what is your problem in organic chemistry. Okay. What you want me to do for organic chemistry. Maximum comments that I see, okay, you can give me any idea about anything. You want to complete organic chemistry in 5 days. You want separate lectures for mechanisms, for naming reactions, for GOC, for isomerism, right? Or you want just question practice of organic chemistry. What exactly you want for organic chemistry? I want to see that, and I want at least 40 plus comments here. Okay? I want at least 40 plus students to comment down what exactly they want. Out of that, I'll see the maximum number of, I would say the maximum students, they are inclined towards which thing? More question practice and less theory, or more theory and less question practice, or only question practice, no theory, or only theory. Okay, so you have 4 options, and I'll be waiting for those things in the comment section. According to that, I'll make one series that is only specific to organic chemistry. Then we will start doing organic chemistry in that way. Okay, understood? Chal. Okay then, beta. I'll see you all. I'll see. I would love to see your comments, right, regarding organic chemistry strategy, right? Okay, chal. Okay then. Bye bye. Take care. See you all in the next class. Bye bye.